Hi, welcome back to the Gabster channel. I'm going to talk today about the Gabster TD1 Dac configuration. This is the updated version of the configuration where I also talk about setting up the DC offset from start to the end in details. There's also some extra configuration of the Gabster TD1 Dac in case you do not want to use the PCM board, which also sounds good as well. And also there's important thing that I'd like to mention is on my Gabster.ca site. I've been updating a lot of things, so check out the user guide section. There's also some areas about configuration, troubleshooting, and make sure you check the beginning of the user guide section where it talks about things you need to do before powering your board, things you need to do before start to installing your board, like downloading the bill of material that a lot of people haven't done so. It's different than the list of parts. And also you need to check out some video links that are part of the site there. So the site will be evolving as we go, so make sure you keep checking it out for extra information. We're going to talk about how to configure it in sim mode, which is my favorite, to configure it in traditional mode and also in balance mode. We're also going to talk about all the different jumpers on the board and how you can get the best sound out of this Gabster TD1 Dac. Now, configuring all the jumpers, what do all the jumpers do? So let's start with these jumpers here. Those two here is if you want DC offset or not. So you can, if you don't want DC offset, you can take them off. This is in case you want to use a capacitor instead. This is J1 and J2. Basically, if you want to provide your own power for the DC offset, you don't want to use the 5 volt that's coming on the board. So you can pull those jumpers out and provide your own 5 volt power for each, either for both of them together or each one of them separately. And then we have a couple of jumpers here. This is for the IV stage, for the OPA 861. This is like your preamplifier stage. So if you want to give this part a separate power, so you take those jumpers out and you give it here +5, 0, and -5. So you do both. You pull all the jumpers out, and now you basically provide separate power for the left, separate powers for the right. These are all great and amazing. I think if you can do that, sure, go for it. But just bear in mind, every time you do that, you're adding more power supplies. Now let's talk about the jumpers on the back. The default Gabster configuration is running with no DEM capacitor, so you cannot see there is no capacitor. And then we are tying the I2S signal to the DEM. And for that, you need to have those two jumpers, so they're on, and that's for that. And also, then this is a mode. So the TDA has different modes. If you look at the data sheet, there's different mode for the TDA. The default mode, this is my default mode, not the regular default mode, is tying the OB to -5 volt. So this is tying the I2S to the DEM. So that's the way I have it. So OB to -5 volts, those two jumpers on, and make sure that the jumper number 24 is not present. This is the version that I like the best. Now, when you are using in sim mode, this is when you need to use all 4 UFL connectors, and you're going to connect those to the PCM board. Anything with sim mode or dual or balanced differential mode, you're going to need that PCM board. So in this case, you are using 4 UFL connectors, and they're going to go to the PCM board. So LRCX, SCK goes to the LRCX and SCK of the PCM board, and then you get data left and data right, and that goes correspondingly to the PCM board as well. Now, if you want to run it traditionally, like the way when it was invented, it's running on most CD players and stuff like that, there was none of these were around. So we pull this jumper out, and then this one here, instead of going from OB to -5 volt, we're going to put it to +5 volt. So you're going to put it to +5 volt, and you're going to install your DEM capacitor here, and you're also going to jumper jump these J24, 2 and 4 pins, so 2 and 4 should be connected together. So you do it like this. So capacitor here, OB to plus 5, and this one gets connected here. Now if you're doing it in this mode, there's a different way to put your UFL connectors. In the traditional mode, you are not using the PCM board. You basically only need to use 3 of the UFL connections. So you'll use the LRCX, the SCK, and the D1DL. So you do not need to use a DR. And basically the LRCK goes to the 504Q7 LRCK, same with the SCK, and the D1DL also as well. So you are using 3 of them, and there is no PCM board in between. Traditional mode without using the DM capacitor, so the jumpers basically you're going to have the J3 and J4 in place here, and your mode is going to be from OB to plus 5 volt. You basically only need to use 3 of the UFL connections, so you'll use the LRCX, the SCK, and the D1DL. So you do not need to use a DR. And basically the LRCK goes to the 504Q7 LRCK, same with the SCK, and the D1DL also as well. So you are using 3 of them, and there is no PCM board in between. Now to run it in balance mode, and as I said earlier, I strongly advise you to run it in sim mode first with just one board and listen to it and try to memorize and listen to that sound, because I want you to use that as a reference. So when you do your balance mode, you can say, okay, did I get a better sound or equal or worse? Because the balance mode is dependent on quite a few things. But let's first talk about how to connect it into balance mode. So everything is the same. So you've got your first board connected just like the first sim mode. So the second board is fairly easy. You're basically gonna get on the back of the I2S to PCM card, just down here, there is 2 also UFL outputs. So one is LLR and one is basically CK. So you're gonna get those 2, the LR and CK, from underneath for the second board. And then you're gonna get DRN and DLN for the second board. And these are gonna go respectively in the DL and DR of the second board. And now you have an inverted signal for the second board. And together you're gonna make a balanced connection. So in balance mode, you must use the XLR connectors on each board, and each board becomes one channel. So one board becomes left channel and one board becomes right channel. If you are running balance mode, all your UFL connectors must be exactly the same size. So if you're doing 10 centimeter, you have to be for both boards, and if it's 15 or whatever, exactly has to be the same. Because at this frequency, a different length could cause a skew in the frequencies and you're slightly out of phase. Also, your TVA chips have to be very close to each other. Even if they are the same date, the same thing, they may not be exactly timed perfectly, and that could also cause issues with the sound quality. To measure the DC offset, I suggest you put your probes one on each side. So you put negative on one side and the positive that you want to adjust. And that's the best way, because if you're trying to put them beside each other, it's going to be tight and it's hard to put the 2 probes together. I suggest you power your streamer first and just play a song, and just any song, just play something and make sure it's displaying that there's something going on. And this is when you can actually turn the DAC power on. So I just turned the DAC power on, and you right away see that there's some fluctuation, but that's because the song is playing and it's going up and down a little bit. So now you're going to pause your music, and that should steady up. And this is when you can adjust the voltage. So because the positive is on this side, we're going to trim this side first. Now small amounts like this I wouldn't worry about, but I'm just showing you how to adjust it. It can go anywhere between plus and minus 2 volts, so just to bear in mind. So right now we are 11 millivolts. That's basically nothing, but we're still going to move it down. Here we go. And that's close enough, so 0.2 millivolts, that's basically nothing. Anyway, if you just have 100 millivolts, don't worry about it. Most amplifier, like I said, can handle DC. It's no problem. I mean, it's not desirable, but it's not like they're gonna kill your amplifier. As long as it's not above 2 or 3 volts, you should be okay. It's not gonna kill it, because even when you have music, it goes fluctuates on plus and minus 2 volts. But we'd like to keep it as 0 as possible. So set it to 0, and then you can always, if it fluctuates a little bit, don't worry about it too much. And the other thing is, if you're using a FIFO Pi by IanCanada and with the Monitor Pi Pro, which I highly recommend, there is a setting in there about the FIFO Pi where you can put it on continuous clock. And if you do that, then you don't have to play a song each time to prevent the DAC from going into a high voltage DC offset. And that will reduce the popping in your speakers and stuff like that. And talking about that, make sure your speakers are set to a slightly lower volume. Don't crank them to the maximum and then plug the power in. You might get a voltage, DC volt going in, and you might hear a big pop on your speaker, or could damage your woofer. Most likely, if you could damage maybe your tweeter or something. It's very unlikely, but I'm just giving you all the layers of safety, so put your volume a little bit lower before you power them. The sequence should be powering your streamer first, then powering the TD1 Dac. And this is going to be, then you're not going to have any DC offset going into your amplifier or your speakers. But again, to be on the safe side, like I said, just put the volume a little bit lower. First time, test it with a cheap amplifier and the cheap speakers, just to be sure that you did not mess up the soldering. You don't have any sloppy solder joints that are shorting things or sending power to the wrong places. If you are running on the UC Pure system by IanCanada using the Ultra Capacitors, there are some things you need to be aware of, a couple of them. First, the voltage fluctuates as things go along. But if you are using the UC Pure Mark III boards and have all your connections to activate the boards and these are the connections I'm talking about, to activate the board basically in between songs and have them charge constantly in between songs, that's going to reduce that effect, and you're going to have more stable voltage. The voltage will fluctuate on how the 5 volt and minus 5 volt are depleted. The lower they go, you start to see a bit of a rise, so it will fluctuate a little bit. That's why it's ideal to have the UC Pure Mark III that charge between songs, because when the voltage starts to deplete down, the DC offset will start to creep up a little bit. And that's kind of normal if your voltage is not steady at 5 volt and 15 volts. So it's something to be aware of. Also, another thing you need to be aware of if you're running on the UC Pure system, if your ultra capacitors are not fully charged, let's say instead of 5 volt you're at 3 volts or something really low, you're going to have this buzz sound and it's going to be very loud. So I would not suggest you run your DAC in this mode. Make sure that your capacitors are at least, have like up to 4.5 volts at least before you power your system, and you're at least above the 12 volts, 13 volts on the 15 volt side. Because anything lower than that, you're going to have this, your TDA is going to not function well, it's going to create this buzzing noise, and you're going to be wondering what the heck is going on. So if you hear that, that would be the culprit. Please note that this has nothing to do with the DC offset in this case. It's just running them on such low voltage causes the TDA chip to actually not function well and causes this vibration and noise. But I would basically turn it off immediately and just wait till you have the proper voltages on your ultra capacitors and then power your DAC again. Once you have it settled at 0, you can then play your music, and then from time to time maybe just check it out. But if you do have an amplifier that seems to react badly to DC, then you might, that would be the ultimate solution, is to put a capacitor in the in between them. Not my preferred way, but it could be your only way. But I've rarely seen an amplifier that kind of really malfunctions in those kind of conditions. But nevertheless, try it first on your own amplifier, and try it on a cheap amplifier first to make sure the first time it's running. Once it's running fine, just to make sure you didn't, solder something wrong and suddenly you've got 15 volts here. Also measure so you see exactly what's going on. So let's measure the other side out of curiosity. We're going to flip those around. And we're just going to measure the other side out of curiosity just to see how it measures. And it's measuring 0.36 volts. So let's adjust that. Now, something to keep in mind, if you power the DAC first and then as a streamer, you are going to have 2.3 volt right off the bat at the beginning. So don't be surprised. This happens if you haven't played anything yet on your DAC. So the best way, the best stable DC offset is to use the FIFO Pi on the continuous clock setting. Use UC Pure Mark III with the sync cable, so you're charging between songs and have a steady voltage. And then the power sequence should be to power up your FIFO Pi streamer first, wait a little bit till that's going, and then start your TD1 DAC power after that. And this way you're going to have the least amount of popping noises, the least amount of initial DC offset, and the most stable DC offset all along. The good thing is the maximum voltage you should get out of here is 2.3 volts. So you're still within the tolerance of most amplifiers in that 2 volts up and down gyration. But you definitely, once you start playing music, you want that to be close to 0 as possible. Somewhere in the 200-300 millivolts, you'll be fine. Please note that the DC offset thing is a TDA chip. It's not part of the IV stage, the amplifier stage. And it's just the TDA will produce a bit of voltage, the amplifier will amplify it, and that's how you get to up to 2.3 volts at the end. And like I said, everybody can do the things differently. If someone wants to put capacitors, they can put capacitors. You simply take those jumpers out, and now you have no more DC offset. You use your capacitors, and you're good to go as well. So you have options. This board can be configured in any way you like. You don't have to use it the way I have it set up, but this is my preferred configuration, and that's what I think where all the magic is happening. When most DIYers get a board, the first thing that comes to our mind, and that's including myself, I bought a few boards, is how we're going to modify it, how we're going to change the capacitors, change this, do this, change the IV stage, use tubes, do this. I know we all want to do that, but trust me, I've spent pretty much over 6 months on this board trying so many different things. I've tried everything you can try on this board, and I've spent nights and days on it. And I came up with this particular conclusion and a favorite mode that I like the best. So at least try it. That's all I'm asking you to do. Just give it a try. And if you want to try different ideas, maybe get a different board, build another one with different ideas, and then you can compare them side by side. Because unless you have an A-B comparison, you're not going to find out if your $1,000 capacitors did make a difference. When changing, for example, capacitors, there's things that are more important than the capacitor itself, its location, how close it is, and sometimes bigger is not better. So there's all these things, and all the parts that are on this board, I've tried different ones, and I came up with these for a reason. So just give them a try and then experiment. And if you find something better, share it with me and with us, and we all would like to learn from each other and try different things. For those who definitely want to try different IV stage, there are basically provisions on the board where you can actually get the sound before the preamplification and use, for example, a tube stage or whatever you'd like to do. But I urge you again to try this IV stage because it is pretty darn amazing. Also, I get a lot of questions on why don't you do this, why don't you do that? And like I said, we all want to change things. So just give it a try and tell me what you think about it. I am running here 4 different DACs. I've got the Gabster D11 here. That's based on the dual mono DAC. And beside it here we have the Denafrips RS2. And here my Gabster TD1 Dac. And below it down here, we've got the Denafrips Terminator. I have compared the Gabster TD1 Dac live basically on a quick change like ABCD with a flicker remote. I can switch between 4 different DACs that I have here right now. And finally, the best sound I'm still liking is my Gabster TD1 Dac. Of course, I'm kind of biased, but it's not just me. It's not, I wouldn't have spent all this time if I wasn't, something that's excites me. What I would like to tell you also is that for those of you who are really want to do the balance mode. With the balance mode, it seems to be a touch and go situation. First, realize that you really have to have the proper length UFL connectors. Anything different, you're in trouble already. Trying to get 2 TDA chips that are close enough, it's hard, especially even if they're somewhat came from similar, you have the similar numbers on them. These are all vintage chips, and we don't know when, like it could be have the same year and stuff, but one could be made, in January, one in December, and they could be some, these are used chips. Some could have overheated over time. Some are being subjected to a humid environment. So it's hard to get that proper chips. I'm not worried about the boards themselves because they can produce some amazing sound, but I think when you're doing a balance mode, you're trying to get the 2 to actually be in synergy, which is because you'll get the good sound, but the holographic sound, which is what this DAC is basically excels in, it starts to sometimes lack when you're doing balance mode. Yet sometimes it sounded good, and I'm still trying to figure out what makes it tick. And why things are changing, and also I haven't built enough power supplies to actually separate like all the parts that I really want to do them, put them in a nice enclosure also would help. So all these things. So all I'm saying is try first do a sim mode in a single-ended configuration and give it a listen because it does sound really good. And sometimes balanced mode is also overrated. A lot of equipment call themselves balanced mode. They're not actually true balanced mode. The best sound I found always seems to be the shortest pass to the sound. So using as little components with the shortest pass. And sometimes when you start to doing balance mode, they were designed initially for long, 100-meter length cables, or for basically commercial bands. And you set up the band is meters away, and you've got the control unit there running all these cables. You need something to reduce. So and then we start doing them. Yes, they have some great advantage, don't take me wrong, but don't get over crazy about balance. Balance may not be the best. So it seems like the balance mode is very dependent on the chips, mostly on the chips, I think. And I'm still trying to source. I've been trying to buy different chips. I bought so many different CD players trying to pull their chips out. I don't like destroying CD players that are running. I usually try to find one that's dead, that's damaged. And often I get one that's damaged and it's in me. I want to fix it. I try to fix it, and some of them I was able to fix. And I said, well, I'm not going to pull the chip out of it now. So I'm limited to how many chips I can pull out. And bought some from here and there in different sources. Some are very trustworthy. I'm actually bought a couple, just waiting for them to come, like the cheapest one from China. I'm trying to see like what, I still haven't had a fake one, like that sounded horrible, but I've been very careful where I buy my chips from. So I'm kind of curious, what would a cheap chip sound like? And see, maybe they're real, maybe they're good. I don't know. I'll find out. I'll tell you about this probably in a few weeks when I get it. So yeah, so balance is dependent on all these things. So it's going to take a bit of time for me to source a few chips that try to match together, so I can give my honest opinion about it. But while we wait for all that, experiment with the sim mode, because it does sound amazing. If you are building the DAC, make sure you watch the build video, especially at the beginning. There are a few things you need to know. They're a must if you are building this, so you don't mess things up. And also the UFL connectors are very tricky. They only have one positive and there's 3 negative. So you have to make sure it's oriented properly. Make sure you use a magnifier. At the beginning it looks like all square, but when you put it in a magnifier, you could see there's a couple little notches on one end, and then you know which side is a positive. So give that all a try, and I'll put a link in here about my first video that I made about the Gabster TD1 Dac for people who have no idea what it is. And in this corner here, I'm going to put a link about the build video about the DAC. There'll be a speaker in the middle if you'd like to subscribe, and also my Patreon link is at the bottom if you'd like to support me. Take care, and I hope to see you again.